Welcome to this explainer. I am so thrilled to have you here today because we are tackling one of the absolute biggest, most persistent headaches in the entire crypto space. Ever since the dawn of decentralized tech, we've faced this massive, fundamental problem. We've built thousands of incredible blockchains, tokens, and ecosystems, but unfortunately, most of them operate like completely isolated countries that just cannot communicate with each other. Well, today, we are going to explore a really fascinating solution to that exact problem.
Here is our agenda for today. We'll be covering the blockchain island problem, the danger of bridges, how chain fusion works, uniting the big three, and finally, the future of Web3. Section 1. The blockchain island problem, a fragmented ecosystem. Think about the original vision of cryptocurrency. It was beautifully simple, right? Cut out the middlemen. But as hundreds and then thousands of projects flooded in, the industry didn't build one massive connected world. It built thousands of disconnected digital islands. I mean, just look at the heavy hitters. Bitcoin, Ethereum, Solana, Avalanche, Polygon, Cardano, Near, Aptos, Sui. Every single market cycle brings a tidal wave of new blockchains, all claiming to be faster or cheaper. But the sheer fragmentation we're dealing with now is just staggering. Every network has its own distinct users, its own separate liquidity, and its own specific gas token you need just to do anything. They are literally cut off from one another.
To really put this into perspective, imagine if your traditional Web 2 experience worked like this. What if your Gmail account literally couldn't send a message to a friend's Outlook address? Or what if every single website you visited required a totally different, dedicated internet connection just to load the homepage? You would think the internet was completely broken, but crazy enough, that is exactly our fragmented Web3 reality right now. As it stands today, Bitcoin cannot natively execute an Ethereum smart contract, and Ethereum cannot directly control Bitcoin.
Section 2. The danger of bridges, security risks.
So early on, the industry thought it found a magic fix, cross-chain bridges. But spoiler alert, the reality turned out to be incredibly complicated, and honestly, incredibly dangerous. We're talking about billions of dollars. And that's not a theoretical number. That is the actual enormous amount of money that has just vanished into thin air due to bridge-related hacks. The underlying reason for this is pretty simple when you think about it. A bridge acts as a centralized point of trust. You lock up your real, native assets in one spot just to create an IOU representation somewhere else. When you pile that much money into one central smart contract, you're essentially building a giant honeypot. Attackers are going to swarm it day and night, probing for any tiny flaw in the code. And to make matters worse, artificial intelligence makes these traditional bridge designs even harder to justify today. AI tools are getting insanely sophisticated, which means security threats and attack methods are evolving rapidly. A centralized vulnerability can literally become an automated target in a matter of seconds. People don't just want basic interoperability anymore. They desperately need secure interoperability, and they want it without having to cross their fingers and trust some unknown third party with their funds.
Section 3. How chain fusion works, beyond messages. This brings us to how the Internet Computer Protocol, or ICP, builds a solution that completely bypasses those old vulnerabilities. Most interoperability systems out there just let one blockchain send basic messages to another. But ICP goes a massive step further. It goes beyond passing messages to directly interact with the assets themselves. It does this using threshold cryptography. So what exactly is that? It's a highly advanced cryptographic mechanism where a single key is actually divided into fragments, ensuring that absolutely no single entity can access or compromise the system without collective network authorization. Let's break this down with a quick vault analogy because this is a real game changer for security. Step 1, your valuable assets are secured in a vault. Step 2, the single key to that vault is essentially shattered into many separate pieces and spread out among participants all over the network, so absolutely nobody individually controls the vault. Step 3, the network has to collectively authorize any action to access it. Through this elegant setup, ICP canisters, which are basically super advanced smart contracts, can interact directly with external blockchains without any centralized middleman holding your keys. The contrast here is absolutely crucial. Traditional bridges rely entirely on wrapped, synthetic, or bridge-issued IOUs. Remember, a wrapped Bitcoin isn't actually Bitcoin. It's just a copy. And every time you make a copy, you add a brand new layer of risk. Chain fusion, on the other hand, relies on direct interaction with the actual native blockchain assets. By dealing with the original asset, you fundamentally wipe out those extra layers of targeted risk that come with fragile bridge copies.
Section 4. Uniting the Big Three. Real-world synergy. Okay, so the theoretical tech sounds amazing. But what happens when you actually bring the titans of the industry together under one unified architecture? It's pretty incredible. You take Bitcoin, the ultimate king of security and value storage, and through chain fusion, it gains native smart contract programmability without ever needing bridges. Then you take Ethereum, the absolute powerhouse for liquidity and DeFi activity, and suddenly you can move those assets with near instant settlement and practically zero fees. And Solana, famous for its blazing speed and transaction efficiency, its assets can now act as unified cross-chain collateral. It's literally the best of all worlds working in perfect concert.
And we aren't just talking about theories here. These applications exist right now. Take the Oizy wallet. It gives you a totally streamlined multi-chain interface. You don't have to juggle 5 different browser extensions or sketchy third-party bridge services anymore. All that heavy, messy complexity is hidden completely under the hood. Then there's Odin Fun, which provides crazy fast settlement and highly responsive infrastructure specifically for Bitcoin runes. These products are proving that when you drastically reduce friction and cut out cloud dependencies, you can offer substantially better, faster, and simpler user experiences.
Section 5. The future of Web3, cooperation over competition. To truly grasp where all of this is going, we have to look at the powerful core philosophy driving this shift. Instead of forcing users to move ecosystems, make ecosystems work together. Right now, most Layer 1 networks are locked in this zero-sum war for absolute dominance. They want to steal developers and drain liquidity from other chains to become the one single destination. Chain fusion approaches the market from a totally different angle. The goal isn't to replace Bitcoin, Ethereum, or Solana. The objective is to be the invisible, connective infrastructure that enhances their utility, making them far more useful together than they ever could be apart.
If you zoom out and look at tech history, this trajectory makes perfect sense. Back in the 1990s, the early web was defined by competing, localized, heavily fragmented networks. But by the 2010s, the modern internet was finally united by common interoperable standards. Think about email providers. They compete for users, sure, but they use the exact same underlying standard to message each other seamlessly. Cloud providers compete, but their APIs integrate smoothly. As we head toward the 2030s, Web3 is on that exact same evolutionary path. Mature industries inevitably move from fierce tribal competition to standardized cooperation. The future of Web3 is undoubtedly multiple blockchains coexisting via global interoperability protocols.
Which brings me to a provocative final thought to wrap up this explainer. Are we going to remain stuck on thousands of isolated digital islands, crossing our fingers and taking on massive bridge risks every single time we move capital? Or will we finally embrace the seamlessly connected ecosystem of the future? Interoperability is clearly going to dictate the next era of decentralized infrastructure. So I'd love to hear your take on this. Are you bullish on a seamlessly connected Web3? Drop your thoughts in the comments. Thanks so much for joining me on this explainer. Stay curious and keep learning.